Today we start a new unit, Unit 7, Graphic Characteristics of Functions. We'll be covering 3 pages, pages 210 to 212. You want to have a graphing calculator and a highlighter. Even and odd functions. A function is even when its graph is symmetric about the y-axis, like a reflection. They were named even functions because the functions x squared, x to the fourth, x to the sixth, etc. are symmetric across the y-axis. But there are other functions that behave like that too, such as the following. This function here is an even function because it has symmetry with the y-axis. This function is actually y equals x squared. This, the B shape, this is a graph of the function y equals the absolute value of x. And this wave shape, this is the graph of y equals cosine x, the trig function. For every point xy on the graph, negative xy is also on the graph. For example, if I take this point here, 2, 4, reflecting over the y-axis gives us negative 2, 4, which is a point on the graph. An even exponent does not necessarily make an even function. For example, y equals the quantity x plus 4 squared is not an even function. And let's sketch that. So we go to the calculator. We can key in x plus 4 squared. Look at the graph. So we still have the graph of the parabola, and actually it's the graph of y equals x squared shifted to the left 4 units. Sketching the graph. It's getting a few points. This graph is not symmetric with the y-axis. The y-axis would act as a mirror image between the two halves of your graph. An odd function, a function is odd when it looks the same upside down. In other words, it is symmetric with respect to the origin, which is the same as 180-degree rotational symmetry. For every point xy on the graph, negative x, negative y is also on the graph. They're named on because of the functions x to the third, x to the fifth, x to the seventh. All have symmetry with respect to the origin. I think that got cut off here. Have origin symmetry. Which is the same as 180 rotational symmetry. Okay, so if I'm looking at this graph here, which is actually the y equals cosine x, or sorry, y equals sine x. This graph here, no special name for that. And if I turn 180 degrees, let's see if I can do that. The image is the same as what we started with. So an odd function has symmetry with the origin, which is the same as 180 rotational symmetry. An odd exponent does not necessarily make an odd function. For example, x cubed plus 1 is not an odd function. Sketch it and show why. And if we go to the calculator, y equals x cubed plus 1. It looks something like this. This is not symmetric with the origin. Neither even nor odd. Don't be misled by the names odd and even. They are just names, and a function does not have to be even or odd. In fact, most functions are neither odd nor even. For example, this one here does not have symmetry with the y-axis, so it is not an even function, and it does not have symmetry with the origin. The same with the second one. Decide if the following graphs are even, odd, or neither. Let's remember. Even, symmetric with y-axis. Odd, symmetric with origin, which is the same as 180 rotational symmetry. A, this is odd. It's symmetric with the origin. B, that's neither. C, that has symmetry with the y-axis. This is even. D seems to have symmetric with the origin. If I flip this around, yeah, it's the same thing as we started with, and the same with our line here. So D and E are both odd functions. F, it's also is odd. G, that has symmetry with the y-axis. This is even. And now H here, this line here is the y-axis, the solid one, and this is the x-axis. So this is neither. So remember, an even function has symmetry with the y-axis. The y-axis acts as a line of symmetry between the two halves of the function. An odd function has symmetry with the origin, which is the same as 180-degree rotational symmetry. Graph f of x equals negative x squared plus 7 and tell if the function is odd, even, or neither. Go to the calculator. Something like this. This is even. And again, keep writing it. Symmetry with the y-axis. It's going to help you to remember. 3 x equals 0.5 x to the third. Minus 5x. It's an odd function, right? If I turn it 180 degrees, it's the same as what we started. Okay, I'm not going to make this all that accurate. And number 4, h of x equals 2 to the x minus 6. This is an exponential function, and it is definitely neither. We've got an asymptote of y equals negative 6. And we are done. Thank you for your attention.